Hi friends, the last video was about the industrial production of citric acid. This video is about the second acid, that is the production of acetic acid. So, acetic acid is systematically known as ethanoic acid. It is a colorless liquid organic compound and have a pungent smell, which is vinegar-like, and dilute solution of acetic acid produced by fermentation and oxidation of natural carbohydrates is called vinegar. A salt, ester, or acyl of acetic acid is called acetate. In the vinegar, the principal constituent is acetic acid, and the first vinegar was the spoiled wine. Glacial acetic acid is the purest form of acetic acid. So the properties of acetic acid is colorless liquid with pungent smell. Melting point is 16 to 17 degrees centigrade. Boiling point 118 degrees centigrade, and the glacial acetic acid is highly corrosive to metals, soluble in alcohol, and is miscible with water, glycerol, ether, acetone, and benzene. It is insoluble in carbon disulfide. So, for a bit of history, acetic acid production is old as winemaking. Okay, that is like 10,000 years back. And in the 3rd century, a Greek philosopher described how the vinegar acted on metals, so it could produce pigments which could be useful in art. And in ancient Romans, they boiled the sour wine in lead pots to produce highly sweet syrup, which is called as sipa. In the 8th century, Jabir ibn Hayyan, he concentrated the acetic acid from the vinegar through distillation processes. In 1847, a German chemist, Hermann Kopp, synthesized the acetic acid from inorganic materials for the first time. In 1910, most of the acid was obtained from the distillation of wood. At this time, Germany is producing 10,000 tons of acetic acid, from which 30% is used for manufacturing the indigo dyes. Microorganisms which are involved are acetic bacteria. The three important genera are genus Acetobacterium. Commonly used species are Acetobacterium aceti, Acetobacterium xylinum. And the second genus is Clostridium. Commonly used species are Clostridium thermoaceticum, which is an anaerobic thermophile. And the third one is acetic acid bacteria, which is Acetobacter and Glucanobacter, which are commonly used. The properties of the acetic acid bacteria. The strains of acetic acid bacteria which are used for production should have these following properties, that are should tolerate a high concentration of acetic acid, and should be required in small amount of nutrients. Should not be over oxidized, the acetic acid formed, and it should be high yielding in producing the acetic acid. The substrates used are ethanol, wine and whey, molasses, fermented grains, malt, and rice. The biochemical process for vinegar production is as seen. So here we can see the ethyl alcohol, and plus oxygen we get acetaldehyde water, which in the further reaction we get a hydrated acetaldehyde, and in the presence of aldehyde and dehydrogenase in the final reaction we get the acetic acid. Production of acetic acid. These are the following steps for the production of acetic acid, that is conversion of starch to sugar by using amylases enzyme. and the anaerobic conversion of sugars to ethanol by yeast fermentation. Ethanol to hydrated acetaldehyde, it gets converted to hydrated acetaldehyde, and then finally by dehydrogenation, the acetic acid is produced by using aldehyde dehydrogenase enzyme. Methods for industrial production. Industrially, they are produced by Orleans surface fermentation, that is trickling generation method, and last one, submerged fermentation method. Orleans method, it is the old and traditional method, but it is slow, but it is a continuous process. High grade vinegar is used as a starter culture. It is done on large containers filled to two-thirds of its capacity. The containers would be filled to two-thirds of its capacity. The wooden containers are laid down on their sides and holes are drilled at the top and end sides of the barrel. Then ethanol is poured into a container using long necked funnels from top. A pictorial representation is coming, so you would be familiar with it. Then after this, then add a starter high grade vinegar. Ethanol is converted into acetic acid within a few weeks, that is like 35 days. And netting or screens are placed over holes to prevent the insects entry into the barrels. The barrels are allowed to sit for several months. The temperature is kept at between 21 to 29 degrees centigrade. From this, samples are taken periodically by inserting a spigot into the side of the holes. When alcohol is converted to the acetic acid, it is drawn off through the spigot. About 15% liquid is left to blend with the next batch. So here this is the pictorial representation of Orleans, or also known as open vat method. So here we can see the barrel is filled to 60 to 70%, and there is a tap from which we can withdraw the product. And as we said earlier, there are holes in the barrels for the aeration and a pipe to refill the substrate. Next is surface fermentation method. It is also known as trickling system, most commonly used industrial method for the acetic acid production. And surface fermenter or the barrel, it is filled with the vinegar, moistened beechwood shavings. The substrate alcohol is then poured from top of the container and slowly dripped down through the shaving fillings. Oxygen is then allowed to container through two routes, one through the hole that have been punched into the sides of the vat, and the second through the perforated bottom of vat. So those are the two routes of aeration, and the air is introduced through the holes by air compressors. When alcohol reaches to the bottom of vat, usually within a span of 3 days, it will be converted into acetic acid. The following conditions are kept under control, and the pH range is from 2.5 to 3.2. Temperature is between 20 to 30 degrees centigrade, and 80 to 88% vinegar will be produced by this process. The advantage of this process is it is low cost, ease of control, high acetic acid concentration, and less space is required. Submerged method, it is the newest, faster, and most efficient method. In an industrial process, 10 to 18% ethanol and 5 times the nutrients used for submerged fermentation are the starting conditions for this submerged method fermentation. When the concentration of ethanol reaches up to 50 to 60% of the solution, it is removed and replaced with a fresh substrate which contain 10 to 18% ethanol. The production plant is filled with large stainless steel containers called acetators. Acetators are equipped with centrifugal pumps at bottom that will pump the air bubbles into the tank. As the pump stirs the alcohol, the nutrients enhance the growth of acetobacter on the oxygen bubbles. Heat jackets keeps the temperature between 40 to 42 degrees centigrade, and in about 72 hours the ethanol is converted to acetic acid. Then the vinegar is piped from acetator to the plate and then framed to filtering machine. The stainless steel plates press the alcohol through the pipe filters to remove any sediment, usually about 3% of total product. The sediment is then flushed into drains while filtered vinegar move toward the dilution station. The advantages of this process is that higher productivity and faster oxidation of ethanol and low cost due to automation. The downstream process and cell separation, the isolation, purification, and concentration of final product determine the feasibility of the process. Cell separation and cell lysis, which is the first operation, can be done by cross flow microfiltration, nanofiltration, electrodialysis. These are useful to concentrate the glacial acetic acid. Applications of acetic acid, they are used as solvent in different industrial processes and an active ingredient in fragrance and perfumes, and for the production of synthetic fibers and textiles. It is also used to make ink and indigo dyes, and also for manufacturing of rubber and plastics. In specific areas, like in medicinal industry, it is in the form of vinegar, which is used for the preservation of food, and it also soothes the sunburned skin and to cure from jellyfish stings. Effective tool for cervical cancer screening. And in health and hygiene section, it is added into the hair conditioners, detangles, and deodorant. In household cleaning, it is in the form of white vinegar, which is used in variety of cleaning tasks for removing smears and streaks from mirrors, and to descaling coffee making machines to remove urine odor and pet stain. In food flavorings, it is used as a condiment to produce pickles and as a flavor enhancer and to preserve the vegetables, and in manufacturing of mint sauce and production of rice. So this is all about the production of acetic acid and the industrial production of acetic acid. I hope all of you understood. Thank you.